Section 8 is called the complex numbers, and basically a complex number is where you're going to put a real number, like 3, and then you're going to add an imaginary number with it, like 2i. Okay? Think of them as unlike terms. They can't be combined. Why? Because this one has an I and this one doesn't. Kind of like if it had an x. You couldn't combine 3 plus 2x, so you can't combine 3 plus 2i. But you can combine like terms. So if you had other real numbers, you can combine them. And if you had other imaginary numbers, you could combine them. Now, when you're writing in what we call standard form, you want to put the real number first and the imaginary number second. If you for some reason didn't, it's not the end of the world, okay? But it's just standard form to do real number first, imaginary number second. Okay, so let's look at a couple examples. Example number 1, we're going to take 3 plus 6i, and we're going to combine it with 4 minus 2i. And so we're looking for like terms. So you want to put the real numbers together, and then you want to put the imaginary numbers together. This one's pretty easy. The 3 and the 4 combine to get your 7. And then 6i and minus 2i, or negative 2i, gets you to 4i. Okay. Some of the questions in the book, once you get your answer, they ask you for something called the conjugate. Fancy word for just switching this sign right here. So this is going to become 7 minus 4i, which is going to be important when we start dividing. Okay? So adding and subtracting is super easy. Example 1, we added. Any questions on it? Example 2, we're going to subtract. Just the inverse operation of 3 plus 6i. Now we're going to subtract 4 minus 2i. One way to deal with it is just to take the minus and distribute it out here, right? So if we rewrote this, we would say 3 plus 6i minus 4 plus 2i. And we get a slightly different answer, right? 3 minus 4 would get us negative 1. 6i plus 2i would get us 8i. So it's basically like adding and subtracting with variables, right? Not too bad. Okay, any questions on example 2? All right, let's get into the good stuff. Example 3. Now we're going to multiply. So we're going to have 3 plus 4i, and we're going to multiply that by the binomial 5 plus 2i. And so when you're multiplying complex numbers, you have a 2-term polynomial and another 2-term polynomial. That's like a binomial times a binomial, and you can use what? FOIL for the box. And then always look to see if you can simplify. Okay, so if you end up with an I squared, you can't leave an I squared in there, right? You have to change that I squared just like you did yesterday and simplify it to a negative 1. Okay, so let's start with our F. So first, 3 times 5 is 15. O is outside, 3 times 2i is 6i. I is inside, 4i times 5 is 20i. L is last, so 4i times 2i is 8i squared. Okay, so that I squared right there is where you need to simplify, right? That I squared is equal to what? Negative 1. So we're just going to think of it as times negative 1. So when we go to rewrite it, we're going to have 15 plus, let's combine these two to 26i. And then 8 times negative 1 is minus 8. And then just combine the 15 and the negative 8. I got 7. So 7 plus 26i. Not too bad, right? Example number 4. Any questions on 3? All right. Let's, multiplying is pretty easy. Let's look at dividing. So we've got 5 minus I divided by 2 plus 3i. Okay, and just like you can't have a radical in the denominator, guess what? You can't have an I in the denominator either. So you need to multiply by the conjugate of the denominator. What that's going to do is it's going to force the I squared to the -1. It's going to make opposites of the two middle terms, so they'll cancel out, and you won't have any more i's in the denominator. Okay? So that's why we do it. We're going to multiply by the conjugate of 2 plus 3i, which is 2 minus 3i. And we need to multiply the numerator by the same thing, because that equals 1, right? And now we have a binomial and a binomial in the numerator, so we're going to need to FOIL those. And we have a binomial in the numerator, or in the denominator and the denominator, so we're going to need to FOIL those as well. So we're going to need to FOIL twice. Okay? So let's do the numerator first. Start with f. F is first. 5 times 2 is 10. O is outside. 5 times -3i is -15i. I is for inside, so -i times 2 would be -2i. L is last, so -i times -3i is plus 3i squared. We'll simplify that in a second, but the first time you do it, I recommend just FOILing it out. Don't try and simplify till your next pass, okay? Now let's FOIL that denominator, okay? So f is first. 2 times 2 is 4. Outside, 2 times -3i is -6i. Inside is going to be a positive 6i. That's supposed to happen on purpose. You should end up with opposites, okay? L is last, so positive 3i times -3i is -9i squared. Okay? Now let's go in and simplify, right? So these are obviously opposites. They're opposites, they cancel. And the I squared, we're going to write times -1. So -9 times -1 is actually what? Plus 9. So over here, I'm going to kind of cancel that and write plus 9. In the numerator, these aren't opposites. We will combine them, and it's okay to have an I in the numerator, just not in the denominator, but we can simplify this I squared, right? I squared is times -1. So 3 times -1 is -3. So I'm going to cancel or cross that off and write -3. Now when I go to simplify, it'll make my life a little bit easier, right? So combine the real numbers first. So 10 minus 3, we get the 7. And then the imaginary numbers, the -15i minus the 2i is -17i. And we've got our complex number in the numerator. In the denominator, all the imaginary parts are gone, and we're just left with 4 plus 9, which is 13. All right?